Yeah, so I'm building up another set of jumper cables. These are the short jumper wires that connect my battery groups in series. So I make these out of 12 gauge solid copper wire, and then I made this little fixture to hold the male bullet connectors, and then I can usually get down in here, get that thing filled up with solder, and then you have to let it cool down because it gets pretty hot there. Okay, this time I actually drilled the holes all the way through, so that holds these bullet connectors quite a bit more stable. I guess I should have done that in the first place, but that's how you fine-tune your procedure there. I guess you try it, and yeah, that works a lot better. Then you can just leave it there to cool, and then you pull one out and stick the other one in. These bullet connectors take quite a bit of solder in there. They have a pretty deep pocket. There we go. So I got my 3 jumpers, so that's enough for one 4S battery. So there's that part. And then let me show you the next piece here. This is one of the things I showed you in the previous video where I was building my first set of modules, and I've come up with a little bit better way to make my bus wires. So I still cut a piece of a bare 12 gauge solid copper wire, 6 inches long, which is just longer than half the distance there. So you can see the wire goes from the center out a little bit past the end, and then I can cut these to length afterwards. I was having trouble getting a consistent bend on the end of the wires because I was trying to use needle nose pliers and try to bend at the end of the wire. And so what I did was I took a scrap of aluminum here and I milled a small groove down there. I milled a half of a hole. This is roughly 3/8 of an inch or 10 millimeter diameter there. So you can see that half hole. So the wire would actually go in across the gap there, and then I have a washer and a 1/4 inch bolt that sit on top, and I put this in a vise. And so I shove the wire through and put the bolt over the top so it's sitting on top of the wire, and then I just squeeze the jaws of the vise and it ends up like that. Figure it's easier to show you this way because when it's in the vise you can't see what's going on. But then maybe from the bottom side there you can see how the bolt fits in there, and I get just a perfect half moon shape there, and then I can just make as many of these as I want, and they're all about as close to the same bend as you can get there. And then the way this works is it actually over bends these parts a little bit, because what they need to do is fit into this recess right there and make essentially a full circle. But you can see this top one overlaps the wire coming in from the other side, and likewise this wire overlaps. So what I need to do is just trim off the little bit on the end. So with this jig I bend the wire too much, and then I have to just trim it short. So let's see if we can do that here. So what I need to do is just get a rough idea of how much I've got to take off. So just a little off each end, pretty much the thickness of the wire. So if I just come in here, and let's see if we can get that. It doesn't have to be perfect either. You just have to get it fairly close. And you can always cut off a little more if you need to. So now let's see how that lines up there. Because now these two halves will go together there. And that'll leave a hole right here in the middle for a screw to go through. And then what I do is I've got some of these pre-made. So these are my flag terminals with the female bullet connector. The jumper wires go in here and connect this pack to the next pack. So what I need to do is get one of these down in here, and that one I've got a little bit, I have to grind these down just a bit. And again, it's easy to take off a little bit more if you need to. So I just get them all the way down in that recess. And then the trick is you got to feed one wire in from this end. So you got a hole that big, and you're trying to get that much wire through that little hole. So that's why I went with 12 gauge wire, because it's about as big as I can get in there. So it's a tight fit. You just have to get the terminal on the bottom, and then because then the wires come in over the top. Yeah, there we go. For 4 battery modules, I need 2 wires on the plus, 2 wires on the negative, times 4. So that's 16 bus wires, and I've got to make 3 jumper wires for every 4S battery. So you got to be making a lot of these parts, and making them all exactly the same is a real big help. But there you can see I've got the 2 wires, and I hammer the bent ends flat so I get a little more contact area. And there you can see I have a perfect kind of a football shape, sort of an ellipse of copper wires sitting on top of this tinned copper flag terminal, and then I put a brass washer on top of that, and then run a brass screw through, and then put a square nut on the bottom side. And it makes a really good contact, because when you tin this wire here, so what I do after I put the screw in is I tin this wire, and when you're tinning this wire down this way, the wire on the other side gets hot. So there's heat transfer across there. So it's, I think, a pretty good electrical connection. Yeah, and then just to show you here, this is one of my finished modules. So what I do is I put the batteries in on the negative side, and then I put my spacers in. I showed you that in an earlier video. And then I put the top on and put the screws in to the top into the spacers, and that holds everything together. And then what I do is a quick voltage check. So I check all the cells, plus on top, minus on the bottom, and just make sure I have plus voltage all the way down. They're all roughly 3.7 volts. I just make sure there's nobody turned upside down here before I start soldering. You know, you can do a visual check and see that you've got the positive terminals up, but I just do a voltage check to double check that, because once you start soldering these in, they're really hard to get out. And then what I do, like I mentioned, I pre-tin the heavy wire, and then come back and solder in the fuse wires. So this is 30 gauge tinned copper wire. After I do that, I flip the battery over, and I put my meter probe on the positive bus bar, and then I check each negative for voltage, and that tells me that the fuse wires that are on the bottom are good. And then I come in and solder the heavy wire to the negative terminals. This wire is easy to check. You can look at it and say, yep, that's good and solid. And then the other thing I changed up from last time, these are my balance terminals. I put those on before I do any soldering, because what I had happen on one of my packs, I was working with my fuse wire here, which is really fine, and I was soldering it on here, and one of the ends of the fuse wire touched the bare copper wire down here, and wow, that thing got hot. And it burned my finger, and I couldn't figure out what was going on, because the wire just got hot all by itself. It just touched it here, and then it had touched down on the bare copper here. So now I put my insulated spade lugs on here before I do any soldering. So if you have like bare copper sticking out like that, and you happen to touch the fuse wire, it'll conduct, and this wire gets really hot really fast. And then after you get the fuse wires in, you turn it over and do one more check. So that's actually 3 checks, a visual and then 2 electrical checks, because once you start soldering the first battery is okay, but if the second battery were flipped over, as soon as you soldered that jumper wire on, you're connecting each battery into the parallel group. And if any one of these cells has been flipped over, you've got a short circuit. That way there's 3 tests. So you got a visual test and then 2 electrical tests. Anyway, I got to get busy on this one, so I'll show you what the group of 6 looks like when I get done. And then, like I say, I have to pull the other battery apart. One of these is going in the old battery. The one from the old battery plus 3 of these is going in a new battery. So I'll have 2 4S batteries, about 66 amp hours capacity. It should be about 1 kilowatt hour. So I'll be doubling my battery bank capacity. So that should get me going pretty good. So I'll show you that when I get there. And as always, thanks for watching.